to talk about conjugates. So again, we have to think back to Algebra 2, and we learned about conjugates a couple different times, but the way that we're going to be using it today is to get rid of radicals. So if you remember way back, whenever we talked about a conjugate, say you had 1 over x plus the square root of 2. Okay, we don't like radicals in the denominator. So to get rid of this radical in the denominator, we multiplied by x minus the square root of 2. And this thing that we're multiplying by is what we called the conjugate. And the reason why it was nifty was because it essentially got rid of the radical. What happens is your first two terms get squared, but your middle terms cancel out. You're going to have x times the negative square root of 2 plus square root of 2 times x. Those two are going to cancel each other out. And then your last term is square root of 2 times negative square root of 2, which equals negative square root of 4, which is negative 2. So if you're hung up on the algebra of that, come and talk to me about it. But that's why it's so nifty, because it eliminated that radical. And then the top was this. Okay, so that's what a conjugate is. So now when we get in here, why is it useful? Well, it can also be used to just manipulate the way something looks. So conjugates aren't just used for getting rid of radicals in the denominator. They're also used for just manipulating. And in this instance, if we tried to determine the limit by substitution, we would again have a whole or an asymptote of some kind. So we need to try to get rid of that denominator. And let's try to do that by multiplying by the conjugate of the numerator. So the conjugate of the numerator is going to be the square root of x plus 1 plus 1. Conjugate just means you change the sign in between your two terms. And what you do to the top, you have to do to the bottom. So now from here, we have to do some double distributing. But on top, we know that our two middle terms are going to cancel out. So I'm not going to worry too much about those. And I'm going to write my limit notation. And this is going to become the square root of x plus 1 times the square root of x plus 1. A radical times itself just equals itself. So we're going to have x plus 1. And then the middle terms are going to cancel. And then negative 1 times 1 is negative 1. So our numerator just becomes that. Pretty nice. And the denominator is going to become x times the square root of x plus 1 plus x times 1. So the denominator got more messy. But that's okay. I'm still concerned. Did I do this right? Let me look at my book. I'm having one of those teacher moments, you know, where you're going along and you think you're doing great and then you throw people off. Oh, I see. I just need to keep going with the problem. So we're going to simplify further. If you substitute right now, yeah, you're going to have 0 over 0. So our next line, we have the limit as x approaches 0. And our numerator is x, and our denominator is, I'm going to undistribute that because that was a mistake. Because I should have had the foresight to see that this x down here is going to cancel with this x up here. And I can only cancel it if it's times this other portion. So that's why I factored it back out. And so now we're left with, oh crud, that was a 1 right there. When I factored the x back out, that was a 1. So now we've got the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Now we can plug in 0. And we're going to end up with 1 over the square root of 1 plus 1, which is 1/2. Yay! And we used rationalizing to help. I don't even know why I said that, because rationalizing didn't help. It's conjugating. I just have all kinds of errors in this. You should have just watched the other video from last year.